Thanks a lot. So welcome to my talk about why everything as code might change everything. I certainly believe so. And I know this is a bold claim. So what am I going to talk about today? So the idea of this talk is to introduce you to this concept, everything as code, to explain what the approach is, to give you quite a few examples, and hopefully also to spark some enthusiasm about that approach, right? So it's structured as follows. So I know it's at the bottom, it's very hard to read, but it's basically a what question. What is it? I will first explain to you what everything as code means. I will then show you what you can do with it, what you can do with the principles behind it, and of course, why I think it's such a powerful concept, and also I'll close my talk with a motivation why you should care at all, right? Because in the end, if nobody uses those principles, then you might as well forget about them. I was already introduced, but just to give you some background about myself, what I currently do, I do a little bit of programming every now and then, but I'm mainly a problem solver, right? So I'm a consultant by trade, and I solve problems in the space of infrastructure. Infrastructure as in infrastructure for IT system, let's say virtual machines, container orchestration, things that you typically get nowadays from a cloud provider, and how you deal with those infrastructure problems is one of my area of expertise. But today, I want to talk about everything as code, and therefore I'd like to start with a small example. So let's assume you have a very simple web application. It's based on some web framework. In this example, it's Django. It's a Python web framework. And all you want to do, you want to deploy your single instance web application, right? So you basically have something like the VIScon web application. This is just an example. And you want to deploy it to the cloud, right? So if you go about it very naively, and this is okay, this is for illustration purposes, right? So you might go and say, okay, I go to Azure. What can Azure offer me? So for those of you who don't know, Azure is a cloud provider. It's Microsoft behind it, and it provides IT infrastructure in the cloud, like a virtual machine, right? So that's what I'm going to do first. I want to create my virtual machine in the cloud. They provide a very nice web portal, so I can click, click, click. I can follow their instructions, and I end up, after some magic on their part, I don't know how they do it. I mean, I don't have to know. That's the point. I end up with an Azure VM that is provisioned, provided for me. And then, of course, I have to upload my app to the VM. I have to run it. And hopefully my users can then access my web app. I mean, this is, a very naive way to think about how you want to get the infrastructure needed for your applications. Okay, so now let's imagine a world where VIScon becomes even more popular than it is today, right? And more popular means you have more users, more traffic, they hit your website. So what is the solution? Obviously, you need to scale up, you need to have more VMs, you need to have more instances of your web application. So again, right, if you think naively about it, then you would go to the web portal provided by the cloud provider, you click, 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 okay, now you realize you might need a load balancer because now you have more than one instances, so you create a load balancer, click, 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 so several clicks later, right, because you all do it manually at this stage, you might end up with a very simple architecture like that. Here you have your users, they access your load balancer, and the load balancer distributes the load between your two or more instances, right? And as you can see from this very trivial example, it's a lot of manual work, right? You create those VMs manually with a UI, you click through wizards, you have to enter data yourself. Of course, there are some built-in checks provided by the UI if it provides a good user experience, but it becomes very repetitive. So can we do better? And I wouldn't be here if we couldn't. So let's introduce our first new friend. He's called Terraform. Terraform is an application from HashiCorp that allows you to describe your infrastructure in some configuration language. So they have their own configuration language. It's called Cache Core configuration language, and it allows you to describe what you want, right? I want a load balancer. I want some network infrastructure. I want some virtual machines. And what they then provide is they create an execution plan for you. So it's a tool that you invoke, and it creates a plan, and then you can say, okay, this is what I want, and then it goes ahead and it applies the changes to your infrastructure, right? So the idea is, instead of having to do it manually, and again, if you scale up, if you duplicate your efforts, you describe what you want in configuration files using a well-defined description language. So how does that look like? I mean, we can't go into the technical details in this talk, but what I can show you is just a glimpse of, it's a lot of configuration files, right? But at first it looks like even more effort, right? But now you can invoke, let's call it a magic CLI tool, the Terraform Utility. And Terraform now talks to Azure, for example, and makes sure that what you have specified in those files gets provisioned, and by provisioning we mean gets provided, gets built up, gets instantiated in Azure according to your specification. So it's like a specification in a well-defined syntax. And this is the entire idea behind infrastructure as code. You define what you want in a code-like language. It doesn't have to be code, but in a code-like language. And then you have a utility, a piece of software. In this instance, it's Terraform. It's the name of the actual software that then goes and creates those virtual machines, creates those networks, creates those infrastructure components at the cloud provider of your choice. Okay, so the question is, why should we stop here, right? I mean, we can describe infrastructure declaratively or even programmatically in some instances. Why stop here, right? So it's actually a very small step from infrastructure as code to everything as code, because we can now think about more, right? I mean, your web application might need some form of documentation, right? So you have documentation that can also be represented in a textual form, right? It doesn't have to be a Word document that is then compiled to a PDF. It can be a Markdown file. It can be another textual format. You can also think about compliance as code, right? I mean, when I get my VM from Azure, it might be publicly available from the internet, so I want to make sure it complies with some basic hardening rules, right? Maybe you don't want to have your root SSH logging enabled so that anybody that guesses your password can log in from the internet. I mean, it's just a very trivial example. Obviously, in production, you would go about it more systematically. But actually, why not have those compliance and security controls also in code, right? Because then you can have it together with your application. And there are a bunch more, right? You can have your build pipelines. It's a Python app, right? You have to compile it, you have to package it, and then you might need to upload it. So this is a process. And that process can also be described in code, or at least in a format that can be treated as code. So this is the entire idea behind everything as code. You want to have more and more parts. And this is what I've summed up here. You want to have every aspect and every part of your software system codified. Well, you don't have to have every part codified, but it has benefits if you have more and more aspects and parts of your system codified, because then you can treat those artifacts, and by artifacts I mean configuration files or formal descriptions. You can treat those the same way as code. And this leads me, this is on this slide with a bunch of text, this leads me to a few key principles, right? So in order for something to be regarded as code, it needs to have a textual representation, right? It's something that you need to be able to edit with a text editor. It's not a binary representation, right? And it's defined in a language with well-defined syntax and well-defined semantics, right? Because you want to have, this is the third point, you have to interpret or to compile those descriptions to get your actual stuff that you want, right? Infrastructure as code means take my formal descriptions and turn it into actual infrastructure, actual virtual machines. And it's the same with documentation as code. These are my source files, text, but maybe my output format is an HTML website that provides the user documentation, right? So you always have some tool in between that takes your formal specifications, your source artifacts, and turns it into your final artifacts or into your final results. So, and this is basically what everything as code is all about, right? If you follow these principles, then you can treat something as code. And this is a very, very important distinction that I'd like to make here, right? I say everything as code and not everything is code. What it means is you treat all those textual representations as if it were source code in a programming language. It doesn't have to be, right? It can be a text file, it can be Markdown, it can be JSON. It doesn't have to be Python or Java or anything, but you can treat it the same way as you would source code. Right? And those artifacts, and I will show you some very concrete examples later, they come in many shapes and forms. I already talked about data serialization language, so you can represent your infrastructure as code in YAML files, depending on the tool. You have markup languages. I mentioned Markdown. You probably know this from GitHub. When you create your README, this is the default format for your README, and it's a way for you to have formatting embedded into plain text. This is Markdown. But of course, you can also have a full-fledged programming language depending on the tool and on the artifacts that we're talking about. All right. So how do you get from those source artifacts, from those representations to your final artifacts? And I mean, this is just, maybe you have described your build pipeline, you have described your infrastructure, you've described your documentation, and it just boils down to we need something in between. We need a compiler, we need a generator, we need an executor that takes those textual representations and turns it into actual infrastructure, right? Someone has to call the APIs from the cloud providers. Otherwise, you won't get anything. Right? Someone has to actually execute your compliance controls. So, something has to test. Does my server comply with my rules? Right? And this is usually a piece of software, and this is basically required for you to turn something in textual form into another representation. I think this is very, very straightforward. Okay, the question now is, enough with the theory. What can you do with it? What can you do with that principle? And how can you apply it, and how does it actually work? And I'm afraid I can't go into the details of each and every tool that I demonstrate. I really encourage you to look them up after the talk. But again, we have Terraform, right? So you have some variables, right? I want to have an instance of type T3 micro. This is something that Amazon Web Services provide. It's just a type of size. And then I want to have my VM in the East US data center. And then I describe my VM, again, in a very plain textual form. And after I have done my description, I can then invoke the tool I was talking about. In this case, it's Terraform apply. and it creates my Amazon compute instances for me. And this is the cycle that gets repeated again and again, right? So it doesn't really matter what's in that code, right? What matters is I have a textual representation. In this case, it's a pipeline for my build process for a Python app, right? So I start with, I specify the Python version, I install my dependencies, I do some tests, and then I create my Python app and I distribute my Python app, right? So I have codified, and this is the key word, I have codified my entire process, my build and deploy process in a textual format. In this case, it's YAML. It's the format supported by Azure DevOps, and Azure DevOps has a cloud offering that allows you to create repositories and have build pipelines, right? In this case, it doesn't even need like a tool on my behalf. I just commit my description to my repository, and when I import it into Azure DevOps, it reads that definition, and then it creates my actual pipeline, right? So it creates all those steps that I have described here, and you can then execute those steps, right? So this is just some of the examples with descriptive languages. You can also have actual code. So I mentioned compliant as code. Here I have an example from a tool called Inspec, and this is Ruby code. Right? I mean, you don't really have to know Ruby to follow what it does. It defines a control. This is just an example, and the title gives you a hint about what it does. It ensures that the root login is disabled on your SSH service. And then it does the actual test. It checks the SSHD config. This is the config on your Linux machines that controls who can log in via SSH. And then it checks that the root login does not compare to yes, right? So this is a property of my target VM that I want to check. Again, I can invoke my tool. It's Inspec. And I get, in this case, I get my compliance results based on what I have codified, right? So again, everything as code is about codifying processes, codifying configuration, codifying best practices, right? Because once I have codified it, I can execute it again, and again. I can execute it on this VM, I can execute it on those 300 VMs over there. And the last example is diagrams as code, right? It doesn't have to be something how to say, just in the realm of programming, right? So I can have my lovely architecture representation as code. I mean, this is not actual code in a programming language. This is planned UML. They have a very distinct syntax, but you can probably follow it. I create my load balancer as a diagram element. I create two virtual machines, and then I connect those diagram elements, and it generates the diagram for me. So I have codified the diagram in textual form, and I have been able to generate it based on my description. Okay, so quickly skip Kubernetes. So why is it such a powerful concept in my opinion? Because it builds upon existing foundation, right? So because all those artifacts, all those formal descriptions I've showed you can be treated as code, you can also use everything that you as a software developer know about, right? You can put it in version control. You can keep track of all the changes, right? It's application agnostic, right? Basically, you only need a text editor. Obviously, you want to have some tool support, so maybe you have an IDE that supports that particular description language, but it doesn't force you, right? It's also agnostic to the workflow, right? So you can have your feature branches, you can have your trunk-based development, you can have whatever workflow you as a software developer feel comfortable with and apply it to all the other artifacts, right? And of course, you can release and tag things, right? If you store them in a Git repository, for example, you can release your infrastructure, right? So this is infrastructure version 2.5, and it has the following properties, and it represents a very well-defined state. Right? So how does that help you, right? So what are the important properties? And I don't go into the details of each, but if you have codified something, it's reproducible. You can run it 1, twice, 10 times, and it always yields, or it should yield the same result, right? It's traceable. If you have it in your version controller system, you can trace the changes. You can see, oh, we have actually changed the load balancer distribution algorithm last week, and you can track that in your commit history. And this is really helpful for troubleshooting purposes. Right? It's also automatable, right? Because it's code and it uses some CLI tools. You can build a pipeline that invokes your processes, right? So you can have a repository with your documentation. Whenever you push a change, you can publish a documentation to a web server because it's all automatical. So it's all automatable and it can be processed automatically. That's the key here. Right. And it's also testable, and we see some examples at the very end. Right. So how does that look like, right? I can have my diagram in GitHub. I can then have my usual workflow. For example, when I moved from that single instance architecture to my multi-VM architecture with a load balancer, I created a new feature branch for my diagram, not for my infrastructure as code. I can do that also, but this is just for the diagram. And then I can have pull requests. If I work in a team, they can review my changes, right? So you can use the same tools that you already know, right? So this is the change from my diagram when I scaled up the VMs, right? The diagram is represented in text. I can do diffs, I can do merges, and we can do reviews. You don't have to change anything about your workflow that you are used to or will get used to when you develop software. And because it's all structured languages, you can have syntax checks, you can have linting. So for example, with plant UML, okay, best practice is to name my diagram in the code, and the editor can actually help me be better at creating those documents. All right. And yeah, so now the remaining question is, of course, why should you care? Right? I mean, yeah, it's a nice concept. Okay, yeah, I can do everything in an editor. Yeah, I can do pull requests for my documentation. I can do pull requests for my build pipelines. But you know, why does it matter? And the reason why it matters is because it's the current trend of the industry. Simple as that. And it's fueled by a lot of buzzwords. We have already seen infrastructure as code. There is also DevOps. I'll talk about that. CI/CD and GitOps, right? So a lot of buzzwords, but this is what's driving those shifts to have more and more automated and have more and more in a representation that is very similar to code. Right. So infrastructure as code, we have already seen. All the major cloud providers, they provide tools to represent their infrastructure in code or as code. And they also strongly recommend you to do it because then you have reproducible infrastructure. And you can delete everything and build it up from scratch. That's the beauty of it. You also have DevOps, right? You might have heard the term. It just means you build the software, but you also have to run it. You own it, right? So you have to be more aware of what does my software run on, You don't have to know the entire stack, but you have to manage at least the higher layers. You need to know whether it's being run on a VM or whether it's run in a container, because you as a developer are much closer to the actual running of your software. This is the trend that we have seen with DevOps. I know this is an entire talk on itself. And then you have all these new systems, continuous integration, continuous deployment. You want to permanently push out changes. You want to have changes being pushed to staging environments as fast as possible. And this drives the need to automate as much as possible. And everything that you can generate from a textual representation can be automated. So it's really a question of speed. And last but not least, you might have heard of GitOps, another one of those buzzwords. It means your repository becomes the single source of truth. It's not only just a repository for your application code, but it also contains the configuration of your entire, or it can contain the configuration of your entire technology stack, and it can now also contain documentation along with it. It can contain all the processes, the build processes that come along with it. Right? Yeah. So this is just to motivate you, and in my opinion, it provides a really nice experience, right? It's everything in one tool. I mean, of course, you can have a different opinion about it, but I really enjoy that workflow. I can edit my actual source code, my Python source code in Visual Code, but I can also edit my infrastructure files, my pipeline files, all in one seamless experience. And last but not least, it's also good news for you as a computer scientist or former computer scientist, because it gives you an edge in the market. Right? And that's because everything as code is just software. It's not just that, but it can be summed up as software development principles applied to a broader domain. And the idea is, if you master one, and you should at least master one, then you master them all. Right? Because it's always the same principles that allows those tools to work. Right? So it gives more power to developers, which I think it's a good thing. And you as computer scientists, you really have the necessary foundational knowledge to just understand how it all works, right? You know what declarative languages are, you know how compilers work, you know how parsers work, and it just helps you, and it also helps you create your own, right? Because as I said, the domains are broadening, but we are not at the finishing line, right? There are still artifacts that can be codified, and maybe you write your next project in the area of data pipelines as code. It's one of the very new hot topics, right? Because it's not enough if you have your Jupyter notebooks and have your data science pipelines in there. At some point, you also want to get production ready, and if you codify your data pipelines in code, it can greatly help you with that. And with that, I hope that I could have sparked some interest. And these are just a few of the examples in that domain. You have the examples that I have shown with Terraform and Plant2ML and Inspec, but there are many, many more, right? You have Ansible with configuration as code. You have, it's really hard to read, but Open Policy Agent, you can have security policies as code. So there are more and more products in that space, and most of them are open source, or at least they have a community edition and an enterprise edition, so you can try them out for free. Well, all of them you can try out for free. And yeah, that's my talk. I finish on the dot. And thank you for your attention. And if you have questions? I think we have time.
Yes, exactly. We have 10 minutes. Perfect. So if you have any questions, just raise your hand. I'll come with the microphone.
Okay. Yeah. So my question is, isn't this like back to the roots for computer science? So when I think of LaTeX, for example, it's like an early example for this, isn't it?
Yeah, that's a very, very good remark, right? So I'd like to compare it to deep learning and AI. I mean, it has been around for years. It just has become more popular in other domains. But LaTeX is a very, very good example where you have document in a textual form. You can even have functions and macros in it. And then you compile it to your final artifacts, right? And it's exactly that. It has now just become very popular in other domains, especially, for example, in the security realm, where you codify your security checks, where you codify your compliance rules. But it's that, right? I mean, infrastructure as code is not a new concept. It has been around for over a decade. But now, with the cloud providers and with the pressure for developers to also do some of the operations, because this used to be a very distinct task, you can now have more and more similar tools based on the same principles. Yeah. So thank you.
I have a question myself. Usually in the workflow of infrastructure, if we, for example, in Kubernetes have role bindings, we define them on the fly. But that goes against code as infrastructure because now I have defined part of the infrastructure without having it in code. Do you recommend, like, what's the workflow you recommend? Should we mirror every change we do into source code automatically, or should the infrastructure people be not allowed to change it on the fly unless in an emergency, but having to commit it, go through the review process, and then roll out the changes?
That's a very, very good point, because we actually experienced that in a lot of projects, right? So I talked about the properties of everything as code. And one of the big advantages is reproducibility, right? You can run your infrastructure as code again, and it should create the same result, right? Otherwise, it violates some of the assumptions. So, of course, it doesn't prevent anyone from changing things manually, right? I have my VM provisioned by Terraform, but I can just log into it and change some properties or even change the SSHD configuration. And this is known as configuration drift. And this is something you want to avoid, right? So every manual interaction deviates from your desired state. And infrastructure as code, if you do everything codified, can help you bring you back, right? So of course it's fine if you create a temporary role binding. You can also create temporary secrets. But if you want to have those properties, then the consequence is that you have to do everything in a textual representation and treat it as code. Because otherwise it's implicit knowledge and it's just in the air, and if someone doesn't know about it, then it might be overwritten, it might be lost.
So it doesn't go against the concept, because I don't want to roll out everything again. So it's fine if I do a temporary change, but adapt the infrastructure files to represent the change if I were to do a complete rollout.
Yeah, okay, so now we get into the technical details of how Terraform, for example, Terraform works, for example. So the idea is you have your desired state in those configuration files. And then Terraform has become very clever over the years, tries to figure out the minimal set of changes it has to apply to your infrastructure to reach that desired state. Right? So when I say you can run it again and again, it doesn't mean it does every change all over. It doesn't destroy your VMs and builds them up again if you deploy them again. It just calculates the difference and then it applies the changes necessary to get on track. Right? So, yes, your configuration, and this is the idea behind GitOps, your configuration should be the single source of truth, and it's versioned, it's managed, it's traceable. If you want those properties, yeah, you have to be that strict. Right? If you don't want those properties, of course, you can do whatever you want.
Hello, that would be a two-part question, I think so. So, at your company, do you perform continuous deployments to production, or is it more like continuous delivery that you are ready to go when the business say, hey, okay, accepted, we are ready to go?
Yeah, I can tell you, in all honesty, none of our customers do continuous deployments, right? Most of our customers are from the insurance sector, or from the banking industry, or from the government. It just doesn't work like that. You always have to have some form of manual manual approval process, but you can still do continuous deployment to your staging environment, right? To pre-production. And yes, we do that.
Mm-hmm. Yeah. So why I'm asking it is really like, I worked for many projects in my IT career, and every time we just wanted to move to continuous deployment, it was always a tough work to get there. And to be honest, only in one company, in one project, we were able to do that. And I am talking about 40 plus projects. So that's why I raised that question. So what we were trying always to do was like, first convince the business, like with continuous deployments to staging or continuous delivery, that we were able to run whenever they say, hey, we are ready to run. And it came out that, hey, it was possible. However, with dividing the end users and customers like to early adopters. So part of instances were already running the newest part of the system, and the rest of the users were running the old system. So there was this continuous deployment that was only deliverable for early adopters. When they were saying, yes, fine, then the business was saying, yes, okay, that's it. And that's why I raised that question, because it's very, very hard topic always.
Yeah, but there are two forces at work. The move to the cloud and the omnipresence of Kubernetes and container orchestration, because in Kubernetes, you describe all the resources in configuration files, in resource descriptor files. So those principles inevitably also arrive at conservative Swiss companies. They are late to the game, but they're not too late. And we've seen a lot of new projects, more in the innovation space, right? They don't touch their system of record. But in the innovation space, when we talk about applications for health insurance providers, your mobile applications, those applications, for example, they are being developed with those principles in mind, at least at the customers I have been working with. Right. But, Swiss companies, especially in those industries, they are a bit cautious, and they are probably right to be so. But, those forces, they are also making them consider those strategies and those principles.
Thanks.
I think we have time for one more question, if anyone has a question.
When adopting everything as code, do you find the hardest problems to be technical, or you sort of mentioned here process and culture-based problems?
If you start from a team that is allowed to follow the DevOps principles and that have a certain autonomy, it's actually quite easy, because then it's up to the team to decide how much of their processes, of the documentation they actually want to have represented in or as code and in the repositories. If you come from that perspective, in my experience, it has actually been quite easy to introduce those concepts, right? If you want, of course, to do that on a global or not on a global scale, but on an enterprise-wide scale, it's never about technical problems or technical challenges, right? As you probably know. Right. So that has been my approach when I work with customers. We usually have a dedicated software development team that is responsible for an app or for a particular service, and then we do a pilot with them where we introduce those concepts. And more often than not, the developers become really enthusiastic about it, and then they talk to their colleagues, and then it spreads. So it kind of spreads organically within a company, at least in the IT department. And then it bubbles up, and then at some point management hears it, and then you talk to them, and there you talk about moving to the cloud, and then you have them in your pocket, so to speak.